Welcome to my kcse revision channel, Teacher James Marita, Girls Boys High School. Kindly subscribe to my channel, click the notification bell such that you get notified once I upload a new video. Today we are looking at for one work. Our topic is classification of substances, and in this case we are talking about separation, methods of separation of substances, and today we are looking one methods of separation of colored substance, which is called chromatography. So chromatography, as we know, is a method which is used to separate a mixture of colored substances which have the difference solubilities. Then we talk about from this word chromatography, we have what we call the chromatology. Chromatology is the study of colors. So if we look at this diagram I have here, so we have some of the principles or the things that you are supposed to understand for you to answer a question well in this question that dealing with the chromatography. So I have a chromatograph paper here. Then we have mixture A. Then we have mixture A. We have substance A. Then we have mixture B, C, D, and E. So you need to understand that there is some of the basic things. One, you have to understand what is the solvent front and the baseline. So in most cases in an exam, the diagram will be drawn, and then a candidate or a student is required to identify, or you will be asked now on the diagram, indicate or label the solvent front and also the baseline. So the solvent front is normally at this point at the upper part. That is where we have the solvent front, and then we have the origin, the starting point from the lower part is where we have the baseline. Now in this chromatography, that we are saying that chromatography is a method which is used to separate a mixture of colored substances. So we have the colored substance here. What are some of the things that you are supposed to understand about these colored substances? The colored substance here now, the most soluble dye, those dyes which are most soluble, they normally move the farthest distance from the baseline. For instance, here, when you compare P, C, D, and E, you realize that E is the most, the E it has moved the farthest distance from the baseline. So it means that dye E it is the most soluble dye. So this one here, the most soluble dye, it moves the farthest distance from the baseline. So if you compare this one here, you realize that dye E it moves the farthest distance from the baseline. It means that now that substance is there, it is the most soluble dye. Then we have the least soluble dye, or we call it the most sticky substance, or the most sticky dye, or the most sticky substance. In that case, it moves the least distance from the origin. So you require now to identify the least soluble dye or the most sticky substance. In that case, you will identify that one as dye P, because dye P it moves the least distance from the baseline. The least soluble dye normally moves the least distance from the baseline, or sometimes we can call them the most sticky substance. We have the pure substances. To identify the pure substance normally separates out into only one spot. So that substance which separates only into one spot, they qualify to be the pure substance. For example, if you are required to identify the pure substance here, substance C, it qualifies to be a pure substance because it separates only into one substance. So that substance or those dyes which separates only into one spot, they are normally called the pure substances. We have the identical dyes in that case. The identical substance or the identical dye in that case, they move an equal distance from the baseline. So, for example, here you can talk of C and E. Sometimes they are moving the equal distance from the baseline. So these two, they have moved the equidistance. They have moved the equidistance from the baseline. So if you require to identify them, we say these one are the identical substances which move equidistance from the baseline. Now, we have the insoluble dye. This one, they do not make any spots. So those insoluble substances is the opposite of the most soluble dye. As we said that the most soluble dye, they move the fastest distance from the baseline. The insoluble dye, in this case, they move zero distance from the baseline. For instance, here we have dye P, which moves zero distance from the baseline. In that case, now we say this one is the most, it is insoluble dye. Then what is a solvent front? A solvent front, in this case here, it is the farthest distance moved by the eluting solvent. That is a simple definition of the solvent front. Then we have the baseline. The baseline, it is a point which the dye to be separated is placed. A simple definition of the baseline. What is now in this case solubility? Solubility is a tendency of a substance to dissolve in a solvent. So the tendency of a substance to dissolve in a solvent, that tendency is called the solubility. We have now the adsorption. The tendency of a substance to stick on the adsorbent material. Now, what the property that makes this separation of chromatography possible? Or sometime in an exam you will be asked now, you state the properties that makes it possible for the separation to take place. For the separation to take place in this chromatography, the substances must have different solubility, so they must have a different solubility for the separation to occur. The substances or the dye must also have the difference in stickiness, or what we call the difference in viscosity. So you talk about the difference in the difference of stickiness of a substance, or the difference in viscosity of the substance. Then we talk of the solubility we have said. Then this substance also, for the separation to take place, they must have difference in densities. So difference in the stickiness of a solvent, the difference in viscosity of the substance. Then we have difference in the solubility of a substance, and then we have the difference in densities. Those are the properties which makes this technique, the chromatography technique, to take place. Now, in this chromatography, we have the most soluble, we have the most, we have the most suitable solvent, which are normally used in this chromatography. So, if you require to identify or to name the most suitable solvent which is used in chromatography, we have a propanol, so you can mention propanol, you can mention propyl, you can mention propylene glycol is also a solvent that can be used there, or you can talk about ethanol. So you either mention the propanol, ethanol, or you talk about the propyl glycol. So those are some of the most suitable solvent which are normally used in the chromatography paper. There is a question where students or candidates are being asked to give a reason why water cannot be used as a solvent. Why water cannot be used as a solvent? Water cannot be used as a solvent because water does not dissolve most of these organic substances or most of the organic compounds, and that is the reason why water cannot be used as a solvent. So in this chromatography paper, that the pen ink cannot be used to draw. Maybe sometime now, ink cannot be used in a chromatography paper. Why? Because the pen ink, it consists some of the resins or the pigments and the coloring material. This coloring material, in this case, or the coloring dyes, they interact with the mobile phase in the system. And that is why now the ink cannot be used. Instead, a pencil can be used because a pencil is made up of either is made up of carbon, is made up of graphite, or is made up of lead. Lead or carbon in that case, they don't contain the pigments or dyes, therefore it cannot interfere with it cannot interact with the mobile phase in the system. So if you are required to give a reason why the ink cannot be used, that's what you can say. Then what we have the RF factor. We have the RF factor in this case. If you are asked now calculate the RF factor, what did you understand by this the RF value? The RF value that this R stands for retention. R stands for retention, and then we have F. This one stands for factor, and therefore now this one we call it the retention factor. How do you calculate the retention factor? Retention factor is normally calculated by the distance moved by the spot or the distance moved by the solvent. So we say that this R retention factor is equivalent to the distance moved by the spot. So we have this is the distance. We have the distance moved. The distance moved by the spot. The distance moved by the spot, and then you divide by the distance moved by the solvent. So we divide by the distance moved by the solvent. So you divide this one by the distance. So we have this is the distance moved by the solvent. The distance moved by the solvent. So the retention factor is normally calculated by the distance moved by the spot all over the distance moved by the solvent. For example, here in my diagram, we have the solvent. The distance moved by this solvent is 28 centimeters. So that the distance moved from this solvent, from the baseline here up to where we have the last spot, is where we have the 28 centimeters. So this one has moved a distance of, it has moved a distance of 28 centimeters. So this is the solvent, it has moved a distance of 28 centimeters. Then we have a distance moved by the spot. In my case here, I have picked spot D, which has moved a distance of 21 centimeters. So D has moved a distance of 21 centimeters. Let's say now that this D has moved a distance of 21 centimeters. So we have the distance moved by the spot. The distance moved by spot D from the baseline is 21 centimeters. The distance moved by the solvent A from the baseline is 28 centimeters. Therefore, to get the retention factor, it is the distance moved by the spot. You divide it by the distance moved by the solvent. In my case here, the distance moved by the spot, the distance moved by the spot in this case is 21 centimeters. You divide by the distance moved by the solvent. In this case, we have this is as 28 centimeters. So if you divide this one, you will get 0.75. Remember, this one has no unit because it is a ratio. So don't forget to put the unit here. This one is a ratio, therefore it should remain like that. So to get the retention factor, the distance moved by the spot or the distance moved by the solvent. You might pick now, for example, here that the distance moved by spots. Let's say if we can make a certain distance here, if P can make a spot here, which is moving at a distance of, for example, 10 centimeters. Let's say now we are using solvent A and spot P, which has moved this distance of 10 centimeters. Therefore, to get that retention factor, it is the distance moved by the spot or the distance moved by the solvent. In this case now, the distance moved by the spot is 10. The distance moved by the solvent in that case is 28. That is how simple you can be able to calculate the retention factor. And one thing you need to understand about this retention factor, the retention factor is always less than 1. So this value here, the retention factor is always less than 1. Why this distance is less than 1? The distance, why this retention factor is less than 1? It is less than 1 because the distance moved by the solvent is longer compared to the distance moved by the spot. So the solvent moves a longer distance compared by the spot, and that is why we have the retention factor. The value must be always less than 1. So if you calculate and then you get a value which is more than 1, then you know that that one is wrong, that one is wrong. Now, sometimes you also required to give some of the 2 or 1 application of this chromatography. You just say chromatography is used in industries to identify the contaminants in foods and drinks. You can also say that it is used in a cosmetic industry, in that case, to identify the harmful substances. And also, you can also say that it is used in the analyzation technique in both pharmacy and medicine to test the purity of drugs. And finally, you can also say that this chromatography is used in it can be used as a allocating agent. It can also be used in sports to identify the illegal substance in the blood content of the athletics. So those are some of the applications of the chromatography. So if you require to give 1 or 2, make sure you understand the application of chromatography, how to calculate the retention factor, the retention factor, and also some of the simple things that we are supposed to know when we are applying this chromatography. We have come to the end of our lesson. Don't forget to subscribe to my channel, watch and share. Thank you for watching.